Alrighty, so in this video, we're going to have a look at the shortcut method for the chain rule. I'm actually just going to go back to the previous example that we worked through without the shortcut method. Now in this question, we had f of x was equal to 3x plus 4 to the power of 20, okay? And we ended up with a derivative of 60 times 3x plus 4 to the power of 19. Now, a couple of things that we're going to look for here to establish what this shortcut method's all about. First thing to notice is that the bracket, or what's in the bracket, right, the 3x plus 4, has stayed in the expression exactly as it was, okay? So 3x plus 4 has stayed in the expression. That was the thing that we made the substitution for. At the start of this, we said let u equal 3x plus 4. So that's still in there, okay? That hasn't changed. The power on the bracket has dropped by 1, okay? So if we think about what's going on there, well, that's something we're used to. We know that we're often subtracting 1 from the power when we differentiate. The other thing that we've got to think about is, where did this 60 come from? And the 60 came from two parts, really. It came from the power of 20 on the outside of the bracket, and also the derivative of what was inside the bracket. It came from that 3. We got the 60 by doing 20 times 3, okay? And you can see that that kind of came when we brought the two bits back together after doing the separate parts of the chain rule. The shortcut method lets you kind of just take that idea, and once you do a few more of these, you'd almost see the shortcut without being taught it, and just jump to this step a whole lot quicker. In words, the shortcut to the chain rule is really differentiate inside the bracket times differentiate outside the bracket. And I like that phrase. That helps you really remember what the chain rule is all about. Another way, a slightly more formal way, is to say that dy dx, or the derivative, is equal to the power times the derivative of the function inside the bracket times the original statement with the power lowered by 1. That's probably a better way of thinking of it, but an easier way to remember, I've always found, is differentiate inside the bracket times differentiate outside the bracket. So let's have a look at another example, and we're going to use the shortcut method. So we're being asked to differentiate y equals 4x to the power of 3 minus 5x, all in a bracket, to the power of negative 2. Okay, so we're going to say, let's use this shortcut to the chain rule and say we're going to go straight to dy dx. Now, the derivative of the inside of the bracket is just the derivative of 4x cubed minus 5x, and that would be, if we do that term by term, 12x squared minus 5, okay, times, right, and because we're multiplying this by something, we're going to multiply all of this. I'm going to chuck a bracket around it, times the derivative, so that was the derivative inside the bracket, times the derivative, or times differentiating outside of the bracket. So if you differentiate something to the power of 2, right, something to the power of negative 2. So if it was x to the power of negative 2, if it was a to the power of negative 2, if it was just blob to the power of negative 2, well, what you would do is multiply by the power, keep your blob there, your x or your whatever it is. In this case, it's just whatever's in the bracket stays there, and subtract 1 from the power. So you get to the power of negative 3. And so, writing that sort of somewhat more neatly, you could say that dy dx is just going to be equal to, put the negative 2 in front, 12x squared minus 5 times 4x cubed minus 5x to the power of negative 3. So all we've really done is found the derivative of what's inside the bracket, and also differentiated around the outside of the bracket, if you like. And that's just a shortcut to the chain rule. Now, you would have got exactly the same answer if you'd done what we did in the previous example and substituted u equals 4x cubed minus 5x. And if you're not sure and you want to be 100% sure, then use that method, right? So use the method we did in example 9, where we let u equal whatever was inside the bracket. But if you can kind of make sense of this and see where it comes from, this is going to be a much quicker way to work in the long term. So as always, it's good to learn the slow way sometimes, but as you get better and better at a method, anytime you can take some shortcuts so that you're still understanding what you're doing, but you can get there a little bit quicker, well, of course, it's always going to be handy in things like exams where you are working against the clock. So as you're working through exercise 9E, I'd suggest try the slow way, where you make the u substitution, but then after you've done a few of those, try doing it the shortcut way, where we're just thinking differentiate inside the bracket times differentiate outside the bracket.